You find yourself gazing at the stars, and suddenly, your imagination is captured by a distant world, Saturn's largest moon, Titan. This celestial body is not just another moon, it is a world shrouded in mystery and wonder, with an atmosphere so thick and rich in nitrogen that it resembles an early Earth. But what truly sets Titan apart are its methane lakes and rivers, painting a surreal and alien landscape that challenges our understanding of what a moon can be. Imagine standing on Titan's surface, surrounded by vast, mirror-like lakes of liquid methane and ethane, with rivers carving through the icy terrain. This is not science fiction, this is the reality of Titan, a world where the rain is not water but liquid methane, and the landscape is eerily familiar yet strikingly alien. The presence of these hydrocarbons creates an environment that is both fascinating and puzzling to scientists. But why does Titan have such a thick atmosphere, and what does it mean for the possibility of life? The answer lies in its unique chemical composition and the processes that have shaped its environment over billions of years. Titan's atmosphere is primarily nitrogen, much like Earth's, but it also contains significant amounts of methane. This methane is constantly replenished, possibly by geological processes or subsurface reservoirs, hinting at dynamic changes occurring beneath Titan's icy crust. As we venture deeper into Titan's mysteries, we uncover the tantalizing possibility of prebiotic chemistry. The complex organic molecules found in Titan's atmosphere and on its surface could potentially mimic the early chemical reactions that led to life on Earth. This raises a profound question: could Titan be a cradle for life, or at least a laboratory where we can study the building blocks of life in a completely different setting? Recent missions, like the Cassini-Huygens mission, have provided us with stunning images and data, revealing the intricacies of Titan's landscape and atmosphere. These findings have only fueled our curiosity, leading to future missions like the Dragonfly drone, set to explore Titan's surface in unprecedented detail. This mission aims to answer some of our most pressing questions about Titan's potential for life and the chemical processes occurring on this distant moon. But the mystery does not end there. Titan's atmosphere is also home to a thick layer of haze, composed of complex organic molecules. This haze is not just a visual spectacle, it plays a crucial role in the moon's climate and chemical processes. Understanding this haze could unlock secrets about Titan's past and its potential to harbor life. As we piece together these clues, we are reminded of how little we truly know about our solar system. Titan challenges our assumptions and invites us to think beyond Earth-centric notions of habitability. Could life exist in a world where methane takes the place of water? The possibilities are as vast and intriguing as Titan's methane seas. So, as we continue to explore and unravel the mysteries of Titan, we are not just learning about a distant moon. We are expanding our understanding of what it means to be a living world in the cosmos. Stay tuned as we delve deeper into the secrets of Titan, where every discovery brings us one step closer to answering the age-old question: are we alone in the universe?